day 3 of metamorphic rocks. Today we're going to look at metamorphic slime and we're going to focus on temperature changes. So let's quickly review first. To change a rock into a metamorphic rock, it needs 3 different things. We have already looked at pressure changes. That was what you did the first day with the squeezing and the stretching of your slime. Then yesterday we looked at chemically active fluids, and we did that by making introducing new metamorphic minerals into the metamorphic rocks, such as the foam, and then the sugar balls and the marshmallows. So now we're going to move on to temperature changes. Now, metamorphic rocks that are changed by temperature you can do this in 2 different ways, because how do you heat up the rock if you think about it? You can do it 2 different ways. You can do this by bringing the rock to the heat, and as you remember, the earth is hotter and hotter as you go deeper into the earth. So if you bury a rock deep enough, you will get it in proximity to really hot environment, so that will metamorphose the rocks. Or the other way you could do it is you could bring the heat to the rock, such as a nearby volcanic eruption, or maybe there's magma that wants to, it's rising and it's rising up to the surface. That will come in contact with the rock that's already there, and what happens is it kind of cooks it. So the atoms rearrange in that cooked area with the aid of temperature, and they make new minerals. And so you have a rearrangement of atoms to make new minerals, and those are metamorphic minerals.
Hi, well, it's been a full day, and we're going to open up our slime after incorporating all that material in, and we're going to see if we can see any metamorphism. So it's pretty non-movement, but you can see in here, if I spread it out, it needs a little help. But look at what happened to these marshmallows. They're sort of bubbly, and they look like they have decomposed. So that indicates a chemical reaction has taken place. They have dissolved. They're soluble in the slime. So we have seen that. You can kind of see in the purple a little bit that there's some color around it. If you see in between the 2 blue balls, there's color around that, and that's maybe a little bit of a contact metamorphism going on. So that boundary is where the slime is going to start interacting with the marshmallow and help break it apart. So those chemically active fluids. Here's this as well, that formerly orangish marshmallow has a little halo around it of darker orange material. So that's the sugar dissolving into the slime. So now our slime is even more sticky because it's got some sugar in it as it has metamorphosed.
Okay, well, what you saw when you looked at your slime and you saw that the marshmallows kind of had bubbly areas around them and looked like they were kind of decomposing or slowly dissolving in, is you saw a form of contact metamorphism. It's not quite the same because it isn't in response to heat necessarily, but it is in response to those interactions, those chemical interactions between different types of material aided by the fluids in there. Now, contact metamorphism is kind of a little bit of what we saw around that marshmallow. If you look at the magma there and think of that as the marshmallow, there's a halo or a little area around it where it starts to, on that boundary, where it starts to have those chemical reactions, those interactions between marshmallow, which is mainly sugar, and the rest of the slime, which is a mixture of alcohol and borax. So that's the type of thing, and it makes contact. So this contact between the two is what eventually uh, helps that mineral dissolve, and it makes sort of a new mineral. That slime has been changed. If you notice it, and if you kind of mold it around in your hands, it's kind of more slimy now. It's more sticky, but it has also changed in that it doesn't run as easily. And so when you hold it up and then let it drip down, it doesn't really go all that quickly. Here's some examples of metamorphic rocks. So this is marble, and this is perhaps not as pretty as you would think marble is. Usually it's not that pure white marble that we saw earlier with the ruby in it, but this is marble nevertheless. It is cooked limestone. So as limestone comes in contact with magma, or if limestone is buried deep within the earth to get higher temperatures, it will metamorphose into marble, and the crystals in it are more tightly fused together. You can't, it's a little more solid and compact of a rock. Here's another example called hornfels, and this is a darker colored rock, and so it's got more darker minerals in it. And in here you can kind of see that the rock altogether is more fused together, but the minerals stay randomly oriented. They're not in kind of a stripe or a band that you would expect if it was directed pressure, like how we saw a few sessions ago. And this final picture shows it really well. The crystals in there, you can see they're still randomly scattered. So that kind of shows you that there wasn't like two sides pushing on it and not the other two sides. It was more or less the pressure was equal in all areas. So that kind of indicates maybe that it was buried, perhaps. And so the pressure was equal on all sides, and it was mostly due to temperature. When you look at the kind of solid looking dark material in the background, that looks like it's a little bit more fused together. It's a little harder, it's a little denser. It's a little more compacted, and that is hornfels. So what we're going to do now is we're going to change the slime in response to temperature. And so although we look at rocks and how they've changed under a heat, we're going to do the opposite because it's easier and it's less kind of iffy to put the slime in the freezer and have it cool down as opposed to heat it up. You could easily get it to the point where it would erupt or something, and that would be an igneous rock, and we're not doing igneous rocks, we're doing metamorphic. So we're going to freeze it instead and look for changes. So here we go.
Hi. Well, now that we have kind of observed our metamorphic slime, we're now going to do the third experiment with slime. We've changed it with pressure, we've changed it by chemically active fluids and introduced new minerals and let them dissolve and become soluble within it. Now we're going to change it due to temperature. And so we're going to put the top on. And what I did not do here, but you need to do, is write on a piece of paper, something like that, just indicate that this is an experiment and that, like, your family members who may not know are not supposed to eat this. This is not edible. And if you looked at it, you'd kind of be like, well, I wouldn't want to eat it, but you want to be safe that, nobody in your family eats this, because I think it would taste bad, but it would probably make you sick because the stuff in the slime is not so great. Nobody wants to eat borax. So with that, and with your, like a Post-it note or something that just says that you're not supposed to eat this, go ahead and put it in your freezer. And we're going to wait and see what happens under temperature to your slime. And there we go. Okay, this video has a bit of a time lapse to it. We set this in the freezer actually last night, and so it has frozen for about 20 hours. So I just took it out of the freezer. Let's see what happened. This is As you can see, it is frozen solid. And so if we want to kind of take it out to make some observations, there. You might have to turn it over and push, and then it should come out. Look at that. It molded into the shape of the company of the cup. And if you feel it, you can feel it, but if it really just feels like something solid. It's not pliable at all. I think if you took a hammer to this, it would probably break, so that would be brittle deformation, not ductile. It's not folding, it's not bending, it's not moving. And so the next thing to do is just to kind of hold it in your hand and watch as it sort of thaws out in your hand. Or just leave it sit in here and see what happens. One experiment you might want to do is put it up like that, and then just take observations as to how long it takes till it thaws and what shape it's in. So this is a bit like crystallizing rocks. They are in fluids or in the magma as a liquid form, so kind of like the slime when it was back in its slime form. Once it cools completely and crystallizes, it's like it's frozen, basically. The crystals are in there, like these foam balls, and they are in there for good if we left it in a frozen environment. So this is just like a crystalline rock. At this point, that metamorphic rock is hornfels or gneiss or something like that, and it's there. So just see what happens, and happy experimenting.
You're kind of done with your slime. This ends the 3 experiments that we did to kind of manipulate the slime. We moved it according to pressure and changed it. We changed it according to adding different minerals to it and watching them dissolve. And then finally we changed it by temperature by putting it in the freezer and freezing it. So those are all the changes that metamorphic rocks go through. And now that you're kind of done with your slime, if and when it ever thaws and it's still kind of slimy, you can go ahead and just play with it, and as long as you want to. When you're done with the slime and you don't want to use it anymore, please throw it in the trash. Don't try to wash it down the sink, because it will clog up your sink. That goes in the trash as well as any of the bowls or the equipment that you used with the slime. So that ends our first section of the chemistry, geology, and metamorphic rocks. Now in the second section, we're going to actually look at rocks and minerals, both metamorphic and non-metamorphic, and then we're going to bead up a necklace. So I'll see you again in video 4.